In terms of where my office is, it's listed in the syllabus, should be. It's listed somewhere. But if you walk down the hallway here, you're gonna pass by the clean room, and then just past that, there's a little hallway with some sort of maintenance room at the end. I'm down that hallway, I'm the only door that's not a maintenance door. And the only door should be with the door George Fox Street outside of it. All right, let's just start out with some basics. I'm not worried about significant figures at the moment. Matter of fact, the only time I care about significant figures is in the first lab. After that, and outside of that, don't care. I've done several videos on significant figures. I will leave that up to you to look at those. It's sort of a love-hate relationship with significant figures, so I figure it's enough, at least you've done it once, and then after that, I don't recall significant figures ever being mentioned in any of the physics stuff that I did other than the textbook. This is approximately my volume, 0.1 cubic meters. And the question is, how many cubic centimeters is that? So, how many centimeters in a meter?
100.
Thank you, I heard that. All right. So, how do I convert this into cubic centimeters?
Dimensional analysis. Dimensional analysis.
Okay.
So like you have to divide it by 100.
So, divide that by 100?
Yeah.
So 0.001 cubic centimeters? Is that what you're going with?
Yeah.
And Abigail?
I was gonna say times 100 over 1, and that would give you
Times 100 versus divided by 100.
yeah.
All right, and fight. Okay, it's one or the other, or neither, actually. There are three choices there. So you're saying multiply times 100, so I got,
Times 100 over 1,
all right, times 100 over 1 y.
because you're doing 1 meter for every 100 centimeters.
So could you just do 1 over 100 just as easily?
Mm-hmm.
What can you multiply by, or what number do you multiply by in order to get the same number?
10 to the power of -3.
All right, I think you're answering a different question. Or are you?
I don't know.
Give me a context. You're talking about this one right
You're
here?
trying to make that centimeters?
No, I wanted it in cubic centimeters.
Right, so you'd multiply by the power of, like 10 power of -3.
Ah,
Or -2, I'm sorry.
so basically this right here.
Yes.
Okay, yes.
I thought, yes.
All right, so you're suggesting,
Yes.
so first off, okay, now the other question. What number do I multiply? If I have a number A, what do I multiply by A in order to get A again? That was awkwardly worded. Hopefully you're going with the spirit of what I just said.
1 over A.
All right. I think you went too far.
Definitely.
All right, I heard a number of other people say 1. When you multiply by 1, you get the number that you started with. All right, so as long as, so whatever I'm gonna do, I have to multiply by 1. What is a fraction equal to 1?
Yep. 1 over 1.
Okay, that's an example. In general, what is a fraction equal to 1?
When you divide it by itself.
When you divide it by itself.
Right.
So
Any
when the
number.
numerator and denominator are equal?
Yeah.
Okay. That doesn't look like 100. 100 does not equal 1.
Sure does.
or does it?
I said it sure does not.
All right, so you're saying that this, no matter what we're doing, this is all bunk? Is that what you're going with?
No,
You wanna stand up and just wonder how they were raised?
not
What wolves?
particularly. Not particularly, no.
Wait, are we going
Okay.
from meters to centimeters?
We're going cubic centimeters, cubic meters to cubic centimeters.
Oh, yeah, I got it.
Why 100?
No centimeters.
All right, so let's start out with 100 centimeters equals 1 meter. Is this a valid statement?
Yes.
Yes.
I hope so, because I've done a whole lot based on that. So the multiplying by 100 over 1 really isn't sufficient, because 100 does not equal 1, despite what I might have said when I was 5 years old. All right, now the numerator and denominator are equal. Units matter. This is not a math class. This is a physics class. Units matter. All right, so centimeters. So which one of these makes more sense?
The top one.
Why does the top one make more sense?
Because you wanna cancel out meters and get centimeters.
All right. So if I want to get rid of meters, I need to, if meters is in the numerator, meters has to go into the denominator.
Yep.
Now, we're gonna do a timeout. And all that was recorded for posterity, so all the international fans can just rejoice. All right, so the top one makes more sense because we want to get rid of meters, and if I have meters in the numerator, I need to divide by meters to get rid of it. However,
There's a different actual amount for, so it's needs to be centimeters cubed and meters cubed, but 1 meter cubed is not equal to 100 centimeters cubed. It's a lot more than that.
yes, it is.
Yeah.
10 cubic centimeters, again, this is my volume. 10 cubic centimeters is about, something like that. It's not particularly big. Unless I'm a time lord and I. So if I will need to convert this, if I need meters cubed, then I need to cube that. And so it's gonna end up being, that's 1 times 10 to the negative 1, so it ends up being 10 to the 5th cubic centimeters. Still working out timing here. Another way of looking at that is if I have, let's say a square. And this is 3 centimeters by 4 centimeters. How would I find the area?
Multiply 3 times 4.
You have to talk louder.
Multiply 3 times 4.
I am gonna nitpick that and I'm gonna say no.
Wait, a square?
Sorry, rectangle. I apologize.
Length times width.
Excuse me?
Length times width.
Okay. Which means what?
Which one is the length and which one's 3 centimeters?
All right, there were too many voices at once. My days of understanding multiple people at once, long gone. Especially, you'll see it in one of the orientation videos. I have tinnitus or tinnitus, depending on what part of the country you're from. So you do need to talk louder. And now some people are a little bit afraid that they're gonna say the wrong thing. Just trust me, you're probably gonna say the wrong thing. It's okay. We all make mistakes. As earlier, when I think I called that a square and then gave it 2 different dimensions. It happens. It's part of the learning process. Okay, so anyway, I forgot what my last question was, other than, length times width, I'm good with that.
Which one is the length and which one is the width?
Answer,
4 is the length and 3 is the width.
why?
And it's longer.
Does it matter?
4.
No.
4 is longer.
So a proper response could have been, because I said so. That-
Makes sense.
There we go. All right, so what do I multiply in order to get the area? Specifically for this problem. Why am I nitpicking 3 times 4?
Oh, because it would be 4 times 3.
Oh, no.
Centimeters.
The math people tell me that it doesn't matter the order in which I multiply. Now, if the math people have been lying to us, then most of my life has been a lie. And then we're gonna get the pitchforks and the torches, and we're gonna go storm the math people. All right, so, did somebody else say an answer that was brilliant?
Centimeters.
Centimeters. 3 centimeters times 4 centimeters.
There we go. Yes. What did I say earlier? Units matter. All right, so my area is 3 centimeters times 4 centimeters. Now the math part, 12. But I'm not done yet.
Centimeter squared.
Yes, don't forget the square, because I got 2 of them there. If I converted it into meters squared, I could go through and do it like similar to what we did over there, or I can convert each one separately, so this is 0.04 meters, 0.03 meters. And now multiply 0.04 meters times 0.03 meters, and I get 0.0012 meters squared. And the reason I'm going through this, and most of you will figure it out, but the reason I'm going through this is just the number of people who, when they do the conversion, like over there, they just they convert one of the units and they don't convert the other 2. There's 3 units there. We get lazy. Some might say efficient. Instead of writing meters times meters times meters, we just write meters cubed because we don't feel like writing much. That's why we have most of our notation, is because we just don't feel like writing that much. So we do symbolic language. I got 3 units here I'm converting. I need to convert all 3. Unless you want to deal with something bizarre, which you probably don't. And I guess it could be 10 meters squared centimeters. Not traditional, it is valid. All right, questions? All right, awkward transition to talk about the lab. The main purpose of today's lab is to learn how to use the instrumentation, and this is the one time you deal with significant figures. How many in here have used vernier calipers before?
Once.
How many have used micrometers before? All right, we've identified 2 of our experts.
Don't say that. Not bad.
All right, I think we have 13 in here now. So, 6, 4, 3, okay, so 13. So I'm picturing a group of 3, 3, 3, and 4. When we get into the other room, we're gonna go to the other room. Actually, I'll probably shoot down to the other room, make sure no one's in there, and then we're gonna take it over. What I'm gonna do is, once you're in your groups, I'm gonna ask for a volunteer from each group to become the expert in the vernier caliper. You're gonna bring people over, I'm gonna teach that one person how to use a vernier caliper. That person is then to go back and teach the group about how to use a vernier caliper. All of you are expected to know how to use a vernier caliper. Then I'm gonna call for a different person to come up and become the group expert in the micrometer. That person then goes back and teaches the other people how to use the micrometer. This does not mean you can't keep asking me questions throughout the entire lab about how to use them. It's part of the learning process. This does not mean that in the future lab, you can't come and ask me questions. Please, if you don't know, ask. Yeah, there's more lab stuff that we will talk about when we get down there, but for right now, I'm gonna stop this. And